In this video, I am going to show you how to take a vector and express it in component form, and then also how to represent it in the plane using a picture by translating it to the origin. This is a common question in actually calculus, sometimes pre-calculus, and physics. And I will show you a couple examples. So the first step is this. Usually you're given something that has the following form. You're given a coordinate system. So I'm constructing one right now. There's your x-axis, there's the y-axis. And then you are told that you have a vector, for example, at the point it begins at 1, 1 here, and it ends at 5, 3. So let's count off here by ones. So I'm going to use my pen. 1, 2, 3, 4, 5. 1, 2, 3. Okay, so you mark another point at 5, 3. So that looks like this. And you're told here's your vector. Okay, the vector begins at 1, 1 and goes over to 5, 3. Okay. And then you are told the following. Find the component form of the vector. So how do you perform this operation? This is what you do. Say V equals, and I use this notation for vectors. You may also use I and J. And what you have is this. You take the difference of the x's and the difference of the y's between the 2 points. Which means mark this one as 1, 1. Mark this one as 5, 3. And then take the difference of the x's, so that is 5 minus 1, that would be the x component, and the y component is the 3 minus 1. Simplify. This is the same as 4, 2. So this is the component form of the vector shown here, and where I am calling it V. The components in picture form are the following. The x component is 4, so that is this one here. The y component is, let me use a marker that's considerably different. Let's use the black here. So that looks like this. Okay, so the red, black is the 2, and the red is the 4. So x component, y component. The x component is 4, count 1, 2, 3, 4, and the y component is 2, just count. So this is what it means to express a vector in component form. And another common question in this context is draw the picture of the vector from the origin. So what you have to do now again is this. You may use the same set of axes, but it gets a little cluttered, so I'll draw a new one. Here are your axes. You will take the vector and move it to the origin. So we'll go from the origin now instead of going from the point 1, 1. Okay, so what you'll do is this. Draw the x component, that is 4. So draw 4 along, right? And then the y component of here we are. So 1, 2, 3, 4. This is your x component. Then turn and draw the y component. So that looks like this. You want to mark each with a little arrow because each component itself could be described as a vector. And then once again connect. There we are. And again, you may want to mark up the axes so everything is clear. 1, 2, 3, 4, 1, 2. This is your x and this is your y. So this is the picture that represents the component form of the vector shown here. This is the original. Find the x component, the y component, move to the origin, redraw so it looks like this. The key concept about vectors is that it doesn't matter where they are located. So in other words, that's the whole kind of underpinning of what we are doing when we are saying express a vector in component form. As long as the direction and magnitude are kept the same, you can locate them anywhere you like, which means the following. This vector here can be drawn from 1 to 5, 3, or from the origin to this point, which has coordinates 4, 2. Or you can draw this vector, if you like, from this point. And then you just do the same thing as we've been doing, which means the following. Begin up from that point, go 1, 2, 3, 4 to the right. Climb by 2, 1, 2. Connect with a line. And this vector is the same as this, which is the same as that one. So for the sake of simplicity, we say express it in component form, because then we take it from the origin as this one is shown here, rather than some crazy point somewhere off in one of the quadrants. Well, let's take a look at another example, although these are fairly routine. So again, I will construct a coordinate grid. And you should be able to construct a coordinate grid as a matter of course. And this is your y, this is your x. And remember, the purpose of a coordinate grid is to help us locate objects relative to the meeting point, which we call the origin, where x is 0 and y is 0. And let's take a look at another vector now. This one will be a little more interesting. So mark up your axes. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. -1, -2, -3. Here we are. So it looks like this. And now next step is this. The vector we are given here begins at the point 2, 1. Okay, and it goes to the point -1, 3. So 1 to the left of 0 and 3 up. Okay, it's going to hit that, cover it up a little bit, that's all right. And now we connect. Here we are. So this is our vector, our little arrow that goes from the point 2, 1 to the point -1, +3. So let's take this vector and express it in component form. So how do we do it? The previous vector I called v. I will call this one also v. It doesn't really matter what you call it. So v, this new v here from this picture where my hand is pointing, is given as follows. You take the difference of the x's and the difference of the y's, and those become the components of the vector. So we have as -1 - 2, and then 3 - 1. So let's simplify. -1 - 2 is -3, and 3 - 1 is 2. So these are the components of our vector. Let's add them to the picture so we can visualize them. So -3 means begin from this point and go 3 to the left. Okay, that's the red. And then the +2 means begin where the red stops and go 2 up. There you go. So those are the components of our vector. And to translate to the origin means the following. Once again, draw coordinate grid. Y, X, marked neatly so it's easy to read. -1, -2, -3, -4, -5. 1, 2, 3, 4, 5. Now draw in the components. So the red one is -3. So remember, you're beginning at the origin and 3 to the left. Then that's a 2, so you turn and you go 2 up. Once you've done this, you draw the vector again. There we are. And now this vector is the same as this one. The only difference is that this one has been translated to the origin in this view here. So next component of 3 negative, a y component of 2 positive. So if I were to label some points now, this would be the point 0, 0, and this is the point negative 3, positive 2. Okay, so this is the general procedure for taking a vector, expressing it in component form, and then drawing a new picture of it from the origin. You may also think of this as taking the coordinate system and translating it to this point of on the vector. Okay, you may also think of this operation that way. In other words, you're taking the coordinate system and you're moving it and you're aligning it with the vector. Take the coordinate system and move it in such a way that it aligns with that point on the vector. Thank you for watching.